Okay, so far we've noticed many things about Earth. We've talked about the rotation. Earth rotates from west to east, which is why the sun rises in the east and sets in the west. We've talked about the rotational period, which is 24 hours. We've defined the word photoperiod as the amount of time between sunrise and sunset. Notice the diagram that I put up here right now is slightly different from the one that you have in your notes. The one that we have in our notes was already titled for Egypt. However, as we've been going along, we should have noticed that this is now solar noon for any location along the Tropic of Cancer. Excuse me, the Tropic of Capricorn. It would be the Tropic of Cancer if we were in the southern hemisphere. Okay. As we did this, we looked at the different positions of the sun at solar noon. We noticed that at some time, some period, the sun may be directly overhead. However, again, that will not happen if you are above or farther north than the tropics themselves. The sun reaches its lowest point in the sky during the winter solstice, and it's going to be somewhere in between all the days in between winter and summer. The vernal equinox, the autumnal equinox, the sun will be at about the midway point. Okay, when we look at models of the sun appears to change its position in the sky throughout the year. This picture is the same as the last one, but now instead we're looking directly to the south on the summer solstice, the vernal and autumnal equinoxes, and the winter solstice. And here we can see that the sun is either higher or lower in the sky, and the path that it takes across the sky isn't as far. You were able to explain this when we look at Earth's revolution around the sun. Earth revolves around the sun in this direction. Now again, please remember that this is a two-dimensional drawing of something that should be three-dimensional. We know when it's summer or winter in the hemisphere based on the direction the pole happens to be pointing. In this diagram right here, the North Pole, or the northern hemisphere, is tilted toward the sun, so this would be summer. This particular day is the summer solstice. If we go directly across from that, half a year later, now the South Pole is pointed toward the sun, so the northern hemisphere would be at its winter solstice. Because Earth is revolving from the summer solstice, and in this diagram to the right, all the way over to winter, the season in between would be autumn. The position right here, 1/4 of the way through the revolution, would be the autumnal equinox. And if we continue up to the top, after winter, before summer, would be the vernal equinox. Now this diagram right here should help us to understand why the sun appeared to be at different positions in the sky. If we look carefully at the position of Earth on the left-hand side, we can see that the sun's rays are coming in at a much more direct angle in the northern hemisphere. That would position the sun more directly overhead. If we happen to be at the Tropic of Capricorn, the sun would be directly overhead. Here in Connecticut, we're not quite at the tropics. We're at 42 degrees, so roughly 20 degrees away. So instead of receiving a 90-degree angle of insolation, we're going to be closer to a 70-degree angle of insolation. Over here, in the winter, we seem to be looking down towards the sun. That appears to make the sun lower in the sky. Again, the sun hasn't changed its position, but because the northern hemisphere is tilted away from the sun changes position in the sky for us. Okay, again, so what we did here was we took this picture, and instead of looking to the south, instead we're looking at that house that was on the left, so we're looking to the east. Now this house is in the northern hemisphere. The sun's going to rise at different positions. However, the winter solstice, because that's when the sun seems to be lowest in the sky, is when the sun appears to be farthest to the south. During the summer solstice, when the sun is at its highest point in the sky, the sun is closer to our position. Let me draw this a different way. Let's take ourselves and put us in the middle of this shape right here. Okay? This is going to be north, south, east, and west. We'll put ourselves standing at the center right here. Okay. Now we know the sun rises in the east and sets in the west. We also know that the sun is going to appear to be in the southern portion of the sky. So when the sun rises on the summer solstice, it's going to rise at a position that's here, it's going to go up high, and it's going to come down here. Let me do that just a little bit better for you. Okay. So that sun is going to rise up high in the sky, and it's going to set here. If we jump over to the winter solstice, the sun is going to appear to rise farther to the south, and it's going to appear lower in the sky. Okay? And if we took the equinoxes in between, it's going to happen somewhere in between. It's a hard thing to imagine sometimes, but if we take those two pictures and we try to throw them into a three-dimensional vision, this is what we should be able to see. So now if we come back to this picture right here, we see that on the summer solstice in this diagram, the sun is coming down directly right here. It's concentrating all of its rays, all of its energy into a small area. That area will be able to heat up much faster and much better. During the winter, we can see that that energy is spread out over a larger area. Therefore, the sun's heat has to be shared over a much greater area. Compound that with the fact that during the summer solstice and the days surrounding summer, the sun is in the sky for a much longer time period than it is during the winter, and Earth has both a greater time to heat up and more intense rays striking the location. So let's just look at that idea when we look at Earth here. This is the diagram that we've put into our notebooks. We have the equator located at 0 degrees. We have the tropics located at 23.5 degrees south and 23.5 degrees north. If the sun is on this side, the northern hemisphere is in summer. Notice that the tropic is where that location that the sun is shining directly down on. If you looked at the other tropic, way down here, 47 degrees away from that, that would put the sun angles at a 40 to 43 degree angle right there. Not what you would consider to be direct, but not necessarily something that's going to make it extremely cold. The equator that's in between is going to be 23.5 degrees less than 90. So right now the equator is getting a 66.5 degree angle of insolation. If we put our protractor on here and we put in the line for Connecticut at roughly 42 degrees north, which would be right about there. I know it's a little bit slanted, but go with me for now, please. Then that puts us a little bit above that direct ray. Now, if the tropic is at 23.5 and we're at roughly 42, let's again round it to 20 just to make life easy for now. This puts our sun ray at roughly a 70 degree angle during the summer, which is pretty good to keep the light intense. If we jump to the other side, let me get rid of these numbers please. When the sun appears to be on this side of Earth, now the northern hemisphere is pointed away, so you can see that the northern hemisphere is in winter. We just change a couple things. The tropic in the southern hemisphere is now receiving that 90 degree angle of insolation. The equator again is at 66.5 degrees. It had its direct rays on the equinox. This tropic switched places with the other tropic, so this is 43 degree angle. And Connecticut, which we said is about 20 degrees away from there, Connecticut now receives approximately a 23 degree angle of insolation. That really spreads the light out. That doesn't allow much heat absorption in any one area. Again, add on the fact that our photoperiod hours during the winter are much shorter, and that area along that whole 42 degree line is going to be much colder during the winter than it is during the summer. I hope this has helped to clarify some of the information. Make sure that you come to class prepared with questions if you're still a little bit confused.